We've made a lot of changes under the hood in this RSpec release. It's now much faster when processing both videos and large images. I want to show you one way that we accomplish this. Let's start by loading a sample image of Vega. And for the sake of illustration, I'll use the histogram to stretch the image so that we can see the sky background. But looking at this image, what jumps out at you? Notice these wide black margins? Actually, the original image from the camera is just this smaller region. RSpec added the margins to make the image larger. In fact, if we move the orange sample lines to sample just any old region, we can see over on the right those black margins. They're here and they're here. The software has always added these margins for a very good reason. They allow you to rotate the image without losing any data. Let's see how that works. On the rotate window, watch the star and you can see that it never falls off the edge of the image. That's because the black borders RSpec added are there to catch it. 5 or 10 years ago, when camera sensors were small, this was a really important feature. It meant you could squeeze a spectrum onto the longer diagonal of your camera sensor and then after the fact, rotate it to the horizontal. But you know, these days, camera sensors are much larger than they were back then. So there's usually no need to squeeze the spectrum onto the longer diagonal of the sensor. So adding the black margins feature isn't as useful as it once was. Let's see what happens without those dark borders. There it is, the borders are gone. Now watch that star again. As I rotate, it's going to disappear outside the image. In fact, anything in the upper or lower four-corner regions disappears. But here's the thing. By removing the extra black borders, this image is much smaller, so it's much faster than the previous one. Why? Well, since it doesn't have that black border region, the image is literally half the size in pixels. So RSpec is twice as fast on this image. In fact, RSpec is faster on almost any large image, including those from cooled FITS cameras, astronomical video cameras, or DSLRs. So from now on, the default in RSpec is to not add those black borders. How will that affect your use of the program? Well, first of all, because the black borders are gone, you see more of the star image details when you enlarge the image. That can be helpful when positioning the orange capture lines or pointing your telescope or even just focusing. And on modern cameras with large sensors, it's likely that your spectrum only takes up a small amount of the sensor itself. Here, for example, is an image that was captured on a cooled FITS camera. It's about 3,200 pixels across. Notice how short the spectra are. So there's seldom a need these days to squeeze your spectra onto a small sensor by deliberately using the longer diagonal. So there's no longer the need for the black borders and rotation. So our suggestion is that you take a few more moments when you're pointing your telescope to be sure that your star and spectra aren't near the edges of the image. That way, if for some reason you need to rotate them, they'll stay in view and won't require that black border to stay visible. However, having said that, if for some reason you need that black border, you can get it back on the Options screen Advanced tab by putting a check mark here. One quick side note here. If you're using a slit spectrometer, you may have accumulated some calibrations of reference lamps that you reuse from time to time. Now that the black border is gone, the width of the image in pixels has changed from what it was in the past. The data has moved horizontally in the image. Your previous calibration was done on a different sized image and won't be correct. You'll need to recreate those calibrations, or you can use the Options screen here to get the black borders back. And here's another short and simple hint. Rotating an image is expensive. Whether you're rotating by just 1 degree or 100 degrees, RSpec has to recalculate each and every pixel using some complicated math. On larger images, this can take a noticeable amount of time. For most of you, especially if you're using static images, it's not a big deal for the software to take a bit more time to refresh the screen. But if you've noticed on larger image, the software gets a little slow, for best results, spend a little extra time up front getting your grating mounted so that you don't need to use rotation. And there's another good reason you may want to avoid rotation. In some circumstances, rotating an image can introduce some artifacts that show up as noise. So for these reasons, we encourage you, leave your rotation at 0 degrees. In fact, in this release, when you rotate out of 0 degrees, the software will blink the rotate button. If this blinking really bugs you, you can turn it off on the options screen. So now we're on the Live Camera tab. In this release, we've modernized RSpec to be more effective with large format, fast frame rate video cameras. First, a minor cosmetic change. We've moved the open button over here to the left side because some new users had trouble finding the button when it was covered by the right panel. I'll click on the button and I'll select this ZWO camera. What we're seeing here is a live spectrum of a lamp, not a star, here on my lab bench. The first thing to look at here is that the layout in this region is a bit different than in previous releases, but nothing too dramatically different. There's this new frame counter here, and this field shows the current frame rate as processed by RSpec. And this field allows you to limit the frame rate. And finally, here's the size of the frames we're receiving from the camera. So right now, RSpec is processing about 13 frames per second on a camera that has frames that are 3096 by 2080. We'll see more about that in just a moment. And see this gear icon? It's the old configure button. It still pops up a submenu, like the old configure button did, but you know, submenus require 2 clicks, once to open the submenu and a second to select the item. And frankly, I could never remember what the difference was between properties and settings. These both pop up a vendor-specific window, so they're really tough to give a good descriptive name to. So to make access to the submenus easier, there are now these 2 additional buttons, 1 and 2, that do the same thing, but require 1 less click and have generic names. Here's the screen that the ZWO company pops up on button number 1. Mainly, you're selecting frame size here. So here's the thing about frame size. When we're doing video spectroscopy, we're not interested in wide field views. All we really need is our star in the spectrum. So there's no reason to drag along 6, 8, maybe even 16 megapixel frames with all their high cost of processing. So let's shrink this frame down to say 1920 by 1080 pixels, and then we'll click OK. This smaller frame size will run more quickly. You can see the software is now showing the new frame size coming from the camera. A moment ago, we saw RSpec handle much larger frames, but this smaller frame will leave additional CPU processing power for RSpec to use, at times making the program much more responsive. The other thing in spectroscopy is, unlike visual video imaging, we generally don't stack hundreds or thousands of images. So we really don't need fast frame rates. In fact, of course, on astronomical targets, rather than this lamp on my lab bench, we'll need longer and longer exposures. We can configure RSpec to limit the frame rate to, say, 2 or 3 frames a second. Let's do that here with this combo box. When we click button number 2 down here, ZWO shows us this configuration screen. Here's where you'll set your gain and exposure for your particular needs, given your target's brightness, your telescope size, and so forth. Each camera manufacturer will show their own different window here. Let's look at this region of interest tab. Here we can see that, of course, you can move around in a cropped image to help you acquire and center your target. When you're initially acquiring your target, you'll probably use this tab and definitely the previous exposure levels tab a lot. Okay, let's close this screen. Now you see this gear over here? When we click on it, it pops up this video statistics window that can be very helpful. It shows the frame rate from the camera, and it shows the frame rate that RSpec is processing those frames. You probably won't need this frame size section, but this box allows you to cap the frame size in RSpec itself. Normally, we suggest you configure frame size on the camera itself using the number 1 screen we saw earlier rather than here in the software. And finally, you can use these 2 checkboxes down here to flip the image horizontally or vertically if you need to. Another big change in this release is the re-engineered histogram stretch screen. It's much, much faster. So here, even at 3 or even 10 or 15 frames per second with large images, we can stretch the entire image in real time. This is really helpful when you're trying to acquire a target, since the histogram's stretch screen often reveals faint details. This particular video isn't a good example of the stretch. We'll see that later on. When doing video spectroscopy, there are two features that you should be aware of because they consume so many computer resources. The first one I mentioned earlier, the rotate button. As I mentioned, rotating millions of pixels a second is expensive. So again, we encourage you to spend a little more time getting your grating mounted so you don't need any rotation. The other big resource hog is the pixel map. You may recall that the 2D pixel map shows you the pixel values from your sensor. Let's take a look at it. Now the first thing I'm going to do is I'm going to reduce the distance between the orange lines, the capture region, so that we're sampling fewer pixels. Okay, so now there's the exposure for each pixel. I'm going to scroll to the right till I find my data. There it is. So those are the actual pixel ADU values. And the 2D pixel map can handle a lot of data in real-time video or a video playback, but not so for the 3D. It's a real resource hog. It's doing a lot of calculating and display updating. So keep the orange lines really close together and the frame rate down to use the 3D pixel map. You can also speed it up by creating a subregion that you want to sample. Hold the control key down and the left mouse button and just bracket in that region. And you can see there, we're just looking at that one small region between the orange lines inside the red box. And you can see it's relatively fast and it can handle high frame rates because there's so few pixels involved. Okay, now here's a wonderful brand new feature, real-time cropping of video images. It's easy to use. Just use the left mouse button and the control key to frame in an area. Once you've done that, put a check mark down here. You can see in the video, we've done a nice zoom, we can see the image better, and you get a lot more speed because there's so few pixels involved in this. You can even rotate and use the 3D pixel map once you've done this kind of cropping. So the crop button and this new panel here are also available when you're playing back a video file on this tab. So what we've looked at so far really is focused on speeding up RSpec videos. The software has always been fast, and now it's even faster. In most cases, you'll only use a handful of these features, if any of them. But I wanted to show them to you so you knew they were available. I encourage you to experiment in the daytime with these features so you're comfortable using them. Just fire up your camera, even if it's capped, and play with the new controls to get a feel for how they work. So now let's move on to some other new features in this release. We're here on the Image File tab. I'm going to select a different image. Now, there's not much there yet, is there? This is a great example of how the histogram stretch can help you. Let's open it here and select a stretch for the entire image. And then I'll click on Auto Stretch. Aha, there are a lot of stars and spectra that popped into view. And as I mentioned a moment ago, we've re-engineered this histogram stretch window so it's much, much faster in this release. You can even stretch the entire image when using live video. That'll be a big help when acquiring a target. The stretch is also more accurate now because we don't have those black borders to contribute extra dark pixels anymore. For the best results with the histogram auto stretch, it's always a good idea to narrow the capture region down to a specific area that you're studying, like I'm doing here. We'll select an overly wide region for the purposes of this example. Now I'll turn off the entire range checkbox and click auto stretch. Wow, look over here. We can see two different emission spectra, one here and one there. These are two Wolf-Rayet stars in the same field, captured on a C8 with just 40 seconds of exposure at a dark sky site. And glancing over here, we can see that their features seem to be a little bit different from one another. So let's take a quick detour to remind ourselves how easy it is to process these. I'll bracket in the first spectra, and then I'll click on the Calibrate button. Then I'll zoom in and click just for a rough calibration to save time on the peak. And then because I previously calibrated my telescope, I can use 1-point alignment using the dispersion that I determined previously. Once I've done that, I click Apply, and I can close this window. I double-click to zoom out, and there's our calibrated and angstrom spectrum. Let's open the Elements window, and come down here to the Wolf-Rayet WC carbon type element lines. And then shift left click to zoom in. Wow, look at the match between the reference lines in blue and our data. And in fact, if I hover over these two blue lines, we can see that they are carbon emission lines. They're broadened by the intense stellar winds on this Wolf-Rayet star. So isn't that amazing? I'm not going to take the time to calibrate the second spectrum, but if you want to try it yourself, this FITS image file was installed during the update in this folder here. So let's close the elements window, and I'll load onto the profile graph a calibrated version of that second Wolf-Rayet star. I calibrated this earlier in the day before we made this video, just so we could look at it here. There the two are, and you can see they really do have a different set of spectra features. These two carbon peaks we saw earlier really don't appear in the blue. Now, one of the things we can do is use this toolbar button to adjust the relative height to make it a little easier for us to compare the two. So in this field of view on the left, we have two Wolf-Rayet stars, and they have different spectra. Wolf-Rayet stars are fascinating targets. Here we've seen how quickly we can calibrate them in RSpec and how they can differ so much from one another. It's these kinds of spectra that are so exciting because they can encourage us to do more reading on the web to learn the physics behind them and the history of their discovery. Okay, let's get off that detour and back to the new features in this release. So here I've closed that reference spectra and I've double-clicked to zoom all the way out on our two spectra. Oftentimes when working with spectra, we find ourselves needing to zoom in to look at just a given region like I've done here. Suppose we wanted to discard the right-hand spectrum that's just disappeared from view. We've zoomed in, and now I can click on this new toolbar button to delete all of the points that are outside of the current view. I clicked yes, and now it looks the same, but there's no other points that we can pan to the left or right. So that's cropping. I'm going to open a Vega image here to look at something else. Let's quickly do a 2-point calibration after bracketing it in here. I'll click on calibrate. There's the zero order. And again, we're going to use 2-point alignment, so we'll turn that off. There's the hydrogen beta feature, so I'll click on that after positioning in that field. Now, once I've done that, in the past I had to type in that hydrogen beta wavelength, but because it's so frequently used here, we've added this checkbox that will fill in that wavelength, in this case 4861, in one click. Again, just something to speed up, something that one of our users suggested. Thank you. So here's something else that's new. If you're using a slit spectrometer, you may have the need to splice two spectra side by side. I'm going to use a low resolution spectrum in a contrived example so it's easier for you to see here. Suppose I have two spectra that I want to splice. So I've prepared two different spectra that we want to splice here. There's the first one. It's the left-hand side of a low resolution spectrum. And now what I'm going to do is click on reference and load the other spectrum I want to splice onto the reference series. Now, there's a single curve. You know, it's two different colors because it's two different graphs. So what I'm going to do is click on the Math on Two Series menu option. This new option here allows me to splice the two into one profile line when I click Calculate. There, now it's one curve. I'll clean up the screen over on the right to make it a little easier to see what's about to happen, and then copy it back to the main profile. So now we've spliced it. So it's a single curve. Now, one hint, the profile on the left here always has precedence. Overlapping points from the second profile on the right are discarded. So now there's another way to do a splice like this. Why? Well, frankly, I wasn't sure which one users would find easier to use. First, I'll close the math window and then jiggle the orange sampling lines to clear the graph so you can clearly see what's going to happen. So to splice those two pieces of the low resolution spectrum that we saw a few minutes ago, click on the Open button and open them both. Hold the Shift or Control key down and select there's one and there's the second and click OK. Now they both got loaded and spliced together into the single profile line. You know, looking at it now, it looks like this second way is much easier if you've already saved this spectra to the disk. Here's another new feature. I've turned on the measure lines and bracketed in a region, in this case a zero-order star. Down here is a new field that shows the area under the curve between them. This is for some specialized processing that only a handful of users might want. So let's calibrate this again. I'm going to click Calibrate and Reset to go back to pixels and close because I want to show you a neat trick. If I hold the Shift key down and click Calibrate, you can see we flip to angstroms. How did I do that? Well, let's open the calibration window for a moment. When you Shift-click on the Calibrate button, RSpec reloads whatever calibration you most recently saved with this button. It's a handy trick when you're reloading the same calibration you used most recently. But remember, you've got to save it first before you use that Shift click. There it is. So I'm going to pop up the reference library here and slide it over to the side. In the past, when we clicked on a star type, the entire reference spectrum appeared like this. But all of these points here are outside our visible observing wavelengths. So in many cases, we may not need them. So this new checkbox here will automatically crop to just the visual region, like that. So now as we scroll through the reference library and the different blue curves show up for the different star types, the profile graph shows only the visible region, making it far easier to work with. So let's talk about the BESS database. It's a curated pro-am catalog of spectra, many of which have been contributed by amateur astronomers. RSpec can now create the 1D FITS files that databases like the BESS database require. It's beyond the scope of this video to discuss the kind of spectra and the processing and preparation details that databases like this one and any others that may come online require. You'll need to check with the database administrators to determine what contributions they accept and how you get validated for submitting spectra. But let's take a look at how we use it here. We click on this down arrow and we select Save Profile to 1D FITS file. On this screen, you select the details like the observer, the site, the object, and so forth. Once you've completed this tab, you can move on to the Advanced tab, and here's where you can enter optional information that's specific to the particular database you're submitting to. So you'll need to confer with the database administrators to determine how to submit this information to their sites. So back here on the main screen, a few final things to wrap up. I'm going to open a raw image file of Pollux, taken on a DSLR. This header button up here has always shown the FITS file headers. It now shows the header of almost any file type. Let's click on it. Here, for example, is the header of the current image, which is a raw image. Because the sort checkbox has a check mark, this data is sorted with these often used fields at the top for easy access. The Customize button will allow you to sort additional fields to the top if you like. Okay, finally here on the Tools menu, Create Video, we've added this video encoder option so you can encode videos in whatever codec you're using. Now, there's been an important bug fix. Some users experienced a problem with the wavelengths of customized labels here on the appearance screen. That would be these fields here. They weren't being properly read from a saved layout, and that's been fixed. And although it's a bit esoteric, if you have a floating window like this one, and you've dragged it over to a second or third monitor, like this, when you restart the software will now properly put it back on that monitor from which it came. So once again, I'd like to thank all of you for your ideas, your support, and your encouragement. I really appreciate all of your input, patience, and ideas. All the best.